G'day, Tim here. One of our channel supporters posted a question about designing a torch that's just a simple 3 LEDs, and on each button press it turns them on sequentially to the point that you have all 3 on, and then on the 4th press it will turn them off. So I thought rather than trying to answer it, we'd do a quick video which basically has come up with this board and the following video, where if we push the button here once, we get 1 LED, 2 LEDs, 3 LEDs, and again it goes off. And basically it would be driving much brighter LEDs, but for programming purposes this is all we needed. If you'd like to have a project designed for you, just leave a comment below or become one of our Patreon supporters and you'll be in a much higher chance of getting something done. So enjoy the video and leave your feedback below. Thanks. Because this project is aimed at beginners, I'm basically going to be using a pre-built board from Adafruit. It's one of their feather boards which references a particular footprint, and it runs the 80 mega U32.4 chip using standard Arduino, and we'll be programming it using this Arduino software, which is an open source software. Now this board's designed that you can prototype directly onto it, so it's just got some spare pads that you can solder things onto. But I've actually got a board already available, subtly different. It's still a feather, but this one has a radio module on it. So I'm going to be using that because I've already got it, and that is this board just here. We'll be programming it exactly the same, so you don't need to worry that anything will change there. And let's have a quick look at the pinouts. So this is my board here. So we'll look into the detail of it, and I'll just go through the pins we will be using. So we'll go for a larger resolution and zoom in. So the pins that we're going to be using are A0, A1, A2 for my LED drivers. So they'll just be outputs. And then A3 will be my input for my switch, which on each pulse will turn on a different LED, and on the 4th pulse turn them all off. We'll also be using the ground voltage as the return feed for the LEDs and the switch, and the 3.3 volts with a pull-up resistor just to make sure the switch input on A3 doesn't false trigger. So we've got up here the charging and programming through the USB, and on the side here we have a battery connection which allows us to put in a LiPo battery, which I've got one of just here. So it's a 3.7 volt, this one's a 2000 milliamp hour. Doesn't really matter what size you use apart from 3.7 volts, it'll just change how long the battery will last. So we'll go back again, and we're going to look at how to set up the Arduino IDE, the software over here. So if you need to install it, there's a link to install here. But if we go right down towards the bottom, I've already got it installed. There's a guide to copying in the packages to specifically program this board. So all you do is copy this link, and you come back to your IDE and go Preferences. And down here I've already got some in, so if I click that icon to show them in a list, you'll see that I've already got the one they require there, so that will bring in my packages for me. So I don't need to repeat that step. And once that's done, we'll basically have support for the Feather U32U4 boards under the Arduino AVR boards listing. So even though we've installed the libraries, that doesn't mean that the board is necessarily available. So under boards here, we can see all the boards that have been installed. And while there may be some Adafruit, like there is a Feather there specific to the Wi-Fi version of it, the one that I want is not actually in the list. So I'll go into Boards Manager and I'll scroll down. In fact, I'll just type in here Adafruit, and that should filter it down. Okay, so here we have the Adafruit AVR boards, which matches what we had over here. So skimming through, so we've got the Feather U32U4, which will also drive the board that I'm using. So I'll select that one. It's not installed at this stage, so we'll install it. This will take a few minutes, so I'll just quickly fast forward through this, and now we can close. So if I go back to my boards, I should now find in here, I've got my Feather U32. So I'm going to choose that one. Even though this one does have the radio module, I'm pretty confident that that will work, because it just won't give support for the radio. So I've selected that, and now I can start to program my board. So I've brought up my pinout view again. Now I was previously talking about the A0, A1, A2, A3. That references port A, so there's actually ports A, B, C, things like that. In fact, on this one, they get called different numbers for the ports. So it gets a little bit confusing depending on what software you're using to program. But in the world of Arduino, you basically program with pin numbers. So we've got pin 18, 19, 20, and 21 that we'll be using. So A0, as it's labeled on the board, is pin 18 in software. And we need to define those first 3 pins to be outputs, and the 4th pin, A3, to be an input for the switch. The way we do that is in the setup part of the program. I'll just go in for 1 tab to keep it tidy, or 2 tabs. So we need to do something called pin mode. Now case is important in here, and it also helps if I put a P instead of an O. So you'll see it changed orange when I changed that to the correct one. Put in a bracket, and we want to say that pin 18, which is A0, comma output, and outputs in capitals, and a colon on the end to say that's the end of that line. Then we'll just repeat that for the other 2 pins as outputs. So to make that quick and easy, I'm just going to cut and paste. Tidy that up. So we'll say, just double checking, 19 and 20 as outputs. Do 1 more, just bring him back, and 21, whoops, 21 as an input. Again, case, whoops, is critical. So that's set up our pins the way we need them. Next, we need to tell them what to do. Because we need to count how many times the button's pressed to determine what state we're in, we're going to need to add a variable which we'll call button count. So what we do is we create an integer, which is int, and then we go button underscore count, colon, whoops, colon, and that will just hold the value of how many times the button's been pressed. Alright, so when we set up, we need to say button count equals the off state, so let's define that. So button count equals 0 in the initial setup. And the way that we control our actual output is using digital write command. And because we want, when the thing's first powered up, everything to be turned off, I'm just going to go through and do a digital write to everything being low, which is off. So we'll go digital capital write bracket. So we'll do 18 comma low bracket colon, and I'll copy that and paste it a couple of times. Just format them back in line. So we want that one to be 19 and that one to be 20. So that will make sure everything's turned off when we first start. So we don't need this part anymore. We've got all our pin information. So I'm just going to maximize this so we can zoom in. And we'll start writing what's known as pseudocode to control the various functions when we push the button. So pseudocode is basically just a text description of what you're going to do, and then you go in and fill the actual code later. So I'm just going to write some comments in here. So first of all, we want to know if the button was pressed. We then need to know if it's been held down for long enough. It's not just a bit of noise, bit of a spike. So we'll do a thing called debounce, which is where we'll wait for 50 milliseconds. If the button is still pressed, we then wait for it to be released, wait for another 50 milliseconds, and then we'll say, yes, it was definitely pressed and released. So we'll go debounce, and if released. All right, so we've now released it. We want to count it. So increase count. And then we want to determine what lights are on based on what the count currently is. So set LED state. All right. So this, once we add some code, will just constantly loop and go round and round forever, checking the current state and returning the LEDs based on that, whether that be 1 on, 2 on, 3 on, or all off. Going back and filling in the code for each of these lines, or several lines of code here. So we want to test the button. So we go if bracket digital read bracket, and it's 21 is the button input, is equal to 1, sorry, not 1, 0. We want to know when it's been pushed down, which shorts it to ground. Do the following events. So you notice when I hit enter there, it automatically put the closing curly bracket in. All right, so inside of there, we're going to do our debounce. So I'll just move this up. All right, so we're going to do a delay of 50 milliseconds, and that's simple as delay bracket 50, closing bracket colon, so 50 milliseconds delay, and I forgot to put in the comment command. Okay. And then we're going to do a while to make it stay in a loop until the button's released. So while digital read bracket 21 is equal to 0. I've just realized in both of these I stuck the equals in the wrong spot. So we should close that bracket, equals 0 and another closing bracket. Same here. So a double equals means matches, whereas a single equals is applying data to something. So it's an easy one to forget, so it's just one to be aware of. So what this will do is it'll basically just stay in this one line until the button is no longer 0, so it's been released. All right, so once it's released, we want to again do another delay just to again make sure that we don't get any bouncing. So we'll do another delay of 50 milliseconds. So I'll copy and paste that one. If the button is still released, so I can copy this line here. So if it's been released, what do we want to do now? Basically copy that up. So when it's been released, we know that it's a definite, someone's pushed the button, so we want to increase the count, so we'll go count. We do a plus plus, which basically takes the current value and adds 1. And then we need to go through and start to process the rest of the commands. So I've sort of jumped a bit outside of my pseudocode here, but I've got the comments where I want them, so it does remind me as I'm going through. All right, so let's start to set up the states. So there's a function called switch and case, and what that does is it tests if a value is equal to a certain thing. So the switch tests the value, which will be the button count, and the case then says if it's case 1, do this, if it's case 2, do this. So we'll go through it and set all of that up. So that's done with a switch bracket button underscore count, closing bracket, curlies, and inside there we'll have a case of 0. We should always put on each case a break, because without that it will actually continue through every single case. So a break says leave the switch statement. And in between there, what we're going to do is if it's case 0, we're going to say the button is off. So we will just take the all off states and paste them in there. All right, so make my life easy, I'm just going to do a quick cut and paste of that and repeat it several times. So that's button state 1, 2, 3. I'll just make these a bit tidier. Indent, 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 and indent. And the brakes should actually be indented as well. Okay. And the very last thing we do with a switch case is we do a default value. So we go default colon, I will set the button count equal to 0. So we're going to take the button count. So if somehow it's managed to get to a value above what we actually are checking for, we're just going to set it back to the 0 value. So bring that one in. Where's my break there? That one in. Okay, so I've got to update these. So on button press 1, I want LED 1 to be high. On button press 2, I want both 1 and 2 to be high. I could also just put a 1 or a 0 in here. And on 3, it's all of them high. So we're pretty close to being done there. I'm pretty sure that will work. So as it flows through, we've increased the count. The moment that the count gets above, let's reset that to the right spot, that the count gets above the value of 3, which I haven't updated, it will drop it back through the default to 0. It will then loop back, retest the button and flow through. All right, let's tidy this up and then we'll give it a quick test. So I've gone through and tidied up all the code with the indents in the right spot. Not essential, but it just makes it easier to read. Now we could verify now, which would go through and check for any bugs, but I tend to just go straight for upload because that does the verify anyway. Before I do, I'm just going to bring this screen up so you can see what happens down here. So this is what happens while we're outputting it to the chip. So I'll click, and what we should see is first of all it detects the port, it starts the uploading process. Because it was a tiny program, it's done in only a few seconds. All right, what we should then be able to see if I come over to the board is if, first of all the lights are off. So if I press the button once and release, 1 on, 2 on, 3 on, and all off. So I could do that reasonably quickly because it's only a 50 millisecond delay, but it just makes sure that it's a definite button press. It's not just a bit of noise or a dirty button or something like that. It also means if I hold the button down until I release it, I don't actually get the light. Alright, so that's all the programming we're going to do for today. There are a few extra things that I'm going to add to this. So I've been asked to add in a 10-hour timer, so the light automatically turns off after 10 hours and then turns itself back on after 14 hours. I'm not really sure the why on that one. We could, if it was just for daylight, use a light dependent resistor or a photo transistor and automatically turn on and off based on daylight, but we'll do what's been asked. And I'll also look at trying to enable low power mode for the microcontroller, which means until the button is pressed, if it's in all lights off state, it uses almost no power from the battery until someone actually pushes the button to start it. So until we get that done, we'll catch you later.
Yeah, right here, do it. Do it.